Suppose I'm out on the ocean or on a beach looking deep out at the ocean, and I see a set of nice regular waves. So I'm going to draw them very carefully. Okay, I have these waves. I apologize, it's looking a little slanted on the screen. I have these waves, and they're moving towards me. Let's say the shore is over here, and it's moving towards me. I want to be able to describe these with some variables so I can understand how to predict the motion or the impact of this wave. So one thing that jumps out right away is what's called the wave speed. Okay, if I'm looking at this wave, and at one point in time, let's say it's 100 meters out from shore, and then at a later time it hits the shore. Okay, assuming it goes at constant speed, or I guess it doesn't matter, but the speed at which this certain crest right here, this bump, the speed at which it's moving along relative to the beach or relative to the ocean floor is the wave speed. And so I can describe that. It would have a direction to it. I could define towards the shore as positive and say that's a positive velocity and give it a magnitude. So that's the wave speed. Okay. And we're going to have other speeds in place, so we'll have to be very careful to define this as the speed of the wave. So in this case, we might give it a subscript as a speed of the water wave. Okay, we might have a speed on a string as you give a pulse to a string, and that pulse travels along. That would be the wave speed on the string. And we have a relationship that actually we can derive, and the text derives. But the important thing is this is the speed of what's traveling. Okay, whatever is traveling. So we have wave speed. What's some other things we can describe about this? Something we can describe is the wavelength. So if I look from this point, this is a crest, and I look to the next crest. Okay. If I think about that unit, and let me draw. Okay, if I think about that unit on my that section on my picture, and let me just block everything out. Okay, I see a maximum comes down to a minimum and back to a maximum. And if I take that and I move it over, I see that same shape. Move it over, I see that same shape again. Okay. That is called our cycle, or the distance from peak to peak we call the wavelength. Lambda equals wavelength. Okay, and it describes just how the extent of our wave. How long does it take before repeating again? Okay, if I were to look from crest to crest, I'd see that that's going to be the same length. There's no difference there because it's got to repeat. So if I move from there to there and there to there, it's going to be the same length. So this is also lambda. So it's not necessarily from crest to crest. It's from some point to the same point in the cycle. Okay. Now to emphasize that, what if I pick a point right here? Okay. So if I look right there, I can say, oh, well, here's a point right there. It's at the same height, but is that a full wavelength? It's not, because this is not doing the same thing as this point is doing. Okay, if my wave is moving this way, this spot is on its way down to a crest. Okay, this is on its way up. And so the actual next point for a wavelength is here. So it's on, or maybe I could a little more clearly with the picture, since I can't draw it moving. I've got a mountain. I'm on the right side of the crest. Here I'm on the right side of the crest. That makes it a full cycle. So that's also a wavelength. So it's really important to recognize that a wavelength or a cycle has to repeat exactly, not just position, but also how it's moving. So those are all examples of a wavelength. Okay, some other things that we could talk about is we could talk about the period. So if I look at this point, Okay, I'm looking at that point, and then and right as soon as I see that point become, let's say, a crest, I start a stopwatch. Okay, and then this crest moves through, and then the next crest comes through, I stop my stopwatch. Okay, so I had this one travel to there, and then this one travel to there, and in that time interval, this could be T0 and T1. Okay, the time it takes for one crest to go and then the next crest is called the period. Okay. It's the period. And the period and the wavelength are related to the velocity. Okay. If at T0 this is right here, then one wavelength will travel in this period. That must be the speed at which it's traveling. And so we end up with the wave speed, in this case a water wave, is going to be equal to the distance over time. The distance it can travel in one period is one wavelength. And so we have distance over time that are associated with the distance of one cycle and the time of one cycle. And so that's one way to describe our velocity and the wavelength and the period.